Hi everyone! In this video we will express a difference of squares in factored form. Factor 25g squared h minus 9m squared h. Whenever I'm asked to factor and I only have two terms or a binomial, I'm always going to check to see if it falls within the form of a difference of squares. This means that I have some sort of term squared subtracting some sort of term squared, which means that it will factor. If there's an addition sign between the two squares, then it will not factor. So I'm looking for a difference of squares. And that means that I want to see the first term if it's a square and the second term if it's a square. So looking at our terms, I can see that 25 can be square rooted to be 5 and g squared can be square rooted to g. However, the h is not a perfect square. So this right here doesn't follow that pattern. Let's look at our second term. 9 I can square root and get a 3, and m squared can be square rooted to get an m. And again, I have this h that cannot be square rooted. So because that h is in common with both of those, the very first thing I'm always going to check in any single problem that's asking me to factor is look for the greatest common factor. That is the very first step because it'll make the rest of the factoring much smaller and easier. So let's go ahead and factor that out, just like the opposite of the distributive property. So if I bring the h out in front, I'm left with 25g squared minus 9m squared. And now the inside portion follows the pattern of a difference of squares. In fact, 25g squared square rooted gives me 5g, and the square root of 9m squared gives us 3m. This means that I have an h on the outside, and then I have my two binomials, taking the square root of the first and putting it in the first position of each binomial. So we have 5g and 5g here, and then we take the square root of the second and put it in the second position of each of these binomials, 3m and 3m. And then to finish off the pattern, we need one to be an addition and one to be a subtraction. And it doesn't matter, either way works, because when we multiply them together, it'll take care of the addition and subtraction to get rid of the middle term. And we can show that right now by going ahead and doing the opposite, or foiling them together, to see if we get the original problem. So let's go ahead, and first times first gives us 25g squared. Outside times outside gives us minus 15gm. Inside gives us positive 15gm. And last times last gives us minus 9m squared. And we still have the h on the outside. And now we can combine these like terms in the middle, which a minus 15gm plus 15gm cancels out, which is what we were looking for. And now writing the simplified answer, we have h times 25g squared minus 9m squared, and doing the distributive property, we get 25g squared h minus 9m squared h, which does match our original question, which means that our two binomials times this h is the correct factored form of our difference of squares. And we're all done.